Okay, to see it graphically, I've gone ahead and I've put in the left side into y1 and the right side into y2, the original problem with the x's, and I need to make sure I can see the point 4, 4, and 5, 5. So how did I come up with that? Well, I just draw a line in between my equal signs, and I'm going to let the left side determine the x value and the right side determine the y value. So if x is 4, so I choose 4, and I do the math, then over here I should get 4 as my answer. And on this side, if I put 5 in and I do the math, I should get 5 as my answer. So I need to make sure I can see 4, 4, and 5, 5. So for my min, I'm going to start it at 0 and go up to 10. And my y min, I'm going to start it at 0 and go up to 10. All right, hitting graph right now. All right, so it's kind of hard to see, but it is actually meeting it twice here. Here's 1, 2, 3, 4. It's meeting it right about there and then right about there. So just trust, I guess, that you did this right, and I'm going to verify it now by doing second trace, going to the calc, choosing my intersect, and I'm just going to move this arrow more to the left side first and just hit enter 3 times. So I can see that 4, 4 works, and then I'm going to verify it again and choose option 5, and this time move it over more to the right because I know it's supposed to hit it twice. And in my window, you know, if this is from 0 to 10, I know that 5, 5 is here. So just hit enter 3 times, and there's the other one. So what will I draw for a picture? Well, first I'm going to put in my min, or my window range, so 0 to 10 and 0 to 10. And then I'm just going to draw a straight line going across, and then I kind of had a curved line going through that actually did something like this. So here's 4, 4, and here's 5, 5. And on the test, it won't be this difficult to see it. They won't be that close. You will have a very easy picture to see. All right, trying the next one. So first I'm going to solve it. So first I need to isolate the radical, which I've done. Now I'm going to get rid of the radical by squaring both sides. And now to solve for x, I can just get x by itself, so I'm going to get x is 15. So first let's make sure it works algebraically. So I'm going to put 15 in. And this one I will not use my calculator because this is pretty simple. So I'll get the square root of 16. The square root of 16 is 4, so that should work. So how do I see on my picture? First, go to y equals, put the left side into y1. So I'm going to have the square root of x plus 1. Then I'm going to go to y2 and put in 4. And then again, I need to see if x is 15, sorry. So if I do x is 15 over here and I do the math, my y should be 4. So I need to be able to see the point 15, 4. So with the window that I'm in right now, I won't see 15. So I'm going to actually up it up to 20. And then in my y, I should see 4. So I want to adjust that. All right, so here's the first one. And there we go. So I can see it. So first I'll just draw the picture. Kind of just something like this. And then I have a line going across. And I will be verifying this point in a second. The window that we had set up, or I set up, was from 0 to 20 and 0 to 10. And now just verifying that that point is 15, 4, I'm going to do second trace. I'm going to choose the 5th option and just hit enter 3 times because there's only one, the calculator. You don't have to direct it. And that it's there. It's 15, 4. So I've verified both algebraically and graphically that there is no extraneous solution, that the solution works. All right, graphing. You will definitely not have your graphing calculator for this portion of the test. So you'll have to make your table, describe the transformation. You're going to graph both the transformed and the parent, and then the domain of just the transformed. So square roots. On the content check, some people were switching these around. In square roots, we chose the numbers 0, 1, 4, and 9 because I can take the square root of them very easily. So the square root of those numbers are 0, 1, 2, and 3. Okay, so here they are graphed. And I'm not going to connect them. I'm just going to leave them be. Okay? But now I'm going to start dealing with the transformation. So what is the transformation? Well, it's going to stretch by 2. It's going to go right 1 and up 3. So stretch by 2, right 1, up 3. So first I'm going to deal with the stretch, and I'm just going to take all of these y's here and double them, not the x's, the y's. So 0 stays 0, this becomes 2, this becomes 4, this becomes 6, and I no longer need these points. So right now 0, 0 doesn't get to stretch, but 1, 1 has stretched to 1, 2, 4, 2 has stretched to 4, 4, and 9, 3 has stretched to 9, 6. But they're not going to stay there. They're still each going to go right 1 and up 3. So don't forget 0, 0. It's going to go right 1 and up 3. And now this point is going to go right 1, up 3, right 1, up 3, right 1, up 3. And now instead of starting here, it's going to start here. And it's starting at 1, 3. And then it's still going to infinity, infinity. So now when I do the domain, the lowest x is 1, right there, and the highest x is infinity. And the range, the lowest range is now starting at 3, the y, and going up to infinity. The next one is a cube root. So again, with your t-chart, you need to remember that the points we picked for our t-chart were -8, -1, 0, 1, and 8, because we can take all of those cube roots really easily. And so I'm going to graph those really fast. I always do the 8s and 2s first. And then the 1s and 0s make a little diagonal, and I'm not going to connect them, but it's like a very flat S. And so now what I'm going to do is describe the transformation. So it's going to flip. It's going to go left 3 and down 1. So first I deal with the flip, and the flip just says take all of these y's and make them the opposite. So it becomes 2, 1, 0, -1, and -2. So right now, this has flipped to here. This has flipped to here. 0, 0 doesn't flip. It's on the x-axis. This flips down here, and this flips down here. And these are temporary points, because now they're still all going to go left 3 and down 1. So left 3, down 1. This one goes left 3, down 1. 1, 2, 3. This one is going to go left 3. So 0, 0 never flipped. Left 3, down 1. This one flipped to here, and it's going to go left 3, down 1. And this one will go left 3, down 1. And now these are the new points I connect. And you have to do all these pieces on the test to get all the points. So the domain doesn't change. This is still x is going to the left, -infinity, x is going to the right, infinity. Over here, though, the range is going to change. It's going up, so infinity, and on the right it's going down, so -infinity. But regardless, it's still infinity, so the lowest x is -infinity to infinity, and then the same for the range. The lowest will still be negative to infinity. All right, long review, lots of practice. Okay, now we're into the more recent stuff. So we have these two functions, and our job is to either add or subtract them, maybe multiply or divide them, and then evaluate them. So this just says take your two functions, f of x and subtract g of x, and you are able to subtract these because they're both square roots. But first I'm just going to add the opposite. So when I'm done, I'll add the 2 and 4 and get 6 square root of x. And then I'll do the same, but this time I'm going to add them. So 2 square root of x plus -4 square root of x. So when I'm done, I can add these, the 2 and the -4, and get -2 square root of x. Now this just says evaluate in your new version of it. So here's the new version of it after I added them. Just put 16 into here. You can put 16 in here and then add them up, but this will be faster. The square root of 16 is 4. So when I'm done, negative 8 is my answer. And the same thing. I'm just going to put 16 into here. 6 times 4 is 24. Okay? Another problem, but this time we're going to be multiplying and dividing. So I'm going to take f of x times g of x. And now this is problems like the front. I'm going to make houses. I'm going to put half and 8 in a house. And then I'm going to put my x's in a house. And I have two little problems. So I'm going to multiply half of 8, that's 4. And then this, I'm supposed to add the exponents. So if I think of measuring cups, a half a cup and a fourth a cup is 3/4 of a cup. But you could always add a half and a fourth on your calculator and get your answer. And now I'm going to do the same thing, but I'm going to divide them. So here's f of x. And here's g of x. And so I'm going to take a half and divide it by 8. Basically what happens when you make your house, the half moves down here with the 8. But you could also just go to your calculator if it helps, and I would do 0.5 divided by 8. You get that, turn it back into a fraction, and you're going to get the 1/16, which is what we'll get here in a moment. And then my x's. So again, measuring cups, I have a half a cup, and I take away a fourth a cup. That's a fourth a cup. And since there are more x's on top, that's where that 1/4 will end up. But you could always subtract a half and a fourth on your calculator. So anyway, I don't need the 1. You could put the 1, but I'll just put the 16 in the bottom. Now what I'm supposed to do is evaluate this new function. Put 16 into here. If you want to use your calculator, you're more than welcome to. But again, just a reminder that that's the same as the 4th root of 16, which you'll eventually take to the 3rd power. So that's 2. And then 2 to the 3rd power is 8, which you'll take times the 4 and get 32. If you just type this all in, just make sure, some of you need to wrap that in parentheses. And then this says just take your division problem and do the same thing. So I'm going to put 16 in. And you got two ways you could do this. What I'm going to do is just take the 4th root of 16, which is 2, and then take 2/16 and get 1/8. If the other way you could look at this is you could subtract the exponents because they're the same base, and a fourth take away 1 is negative 3/4 or 3/4, and it says that that 3/4 should be on the bottom. And then again, look at this as the 4th root of 16, which is 2, and then take that 2 to the 3rd power and get the 8 that's in the bottom. All right, believe it or not, almost done.